if you've just started a new tech venture and you are moving into a cloud area, I think there are some really useful configurations that you can be aware of when you're kind of operating the cloud for the first time. Over the next few videos, I will look at networks and how you can kind of create this landing zone infrastructure for a new cloud company. One of the first steps I would take is to look at IP address management, and then look at how you can then create a network and how that network could then be later expanded into supporting multiple regions. That would be that's a good starting point if you're operating in the cloud. So in this video, I will talk a little bit about IP address management and how you can create a route of network IPs at the top level that can create multiple VPCs across multiple regions, and that can help you from things like network overlap later on. So let's start with Terraform. This is probably the best way to do it. Of course, you can use other tools if you want. Same applies, or you can also use the UI. With Terraform, it's really straightforward. We're not creating many resources with this. I've created a little module here with nothing in it. So it's just data and main.tf files. I will initialize that module. I've just goes without saying that I've already provisioned and authenticated against AWS, so I can just kind of write infrastructure into my account. So there are plenty of tutorials and videos online you can see about this. But yeah, if you had a resource, you could just directly make a VPC in this way. I have deleted. Let's go to my VPC console. I don't have any. As you can see, you can't see any VPCs. As I was saying before, when you in every region, AWS will create this default network for you. Whether that's a good thing or not, you can argue. But for this case, I've deleted all the VPC, all the networking, everything. So I'm just starting from bare bones scratch here. So the goal is to create an IPAM, so an IP address manager first, and then create this root pool of IPs. And then from there, we can use that pool to create a VPC or to create multiple VPCs in different regions, right? So I'll try to show this as an example with very minimal Terraform kind of code infrastructure here. Another thing to note as well is a little bit about cost. As far as I've seen, costs get endured when you have the advanced tier of IPAM, and you start doing cross-account things. I do also think there's across regions as well, but you don't necessarily have to keep enforced usage of IPAM. It's a good reference starting point to know, just to map out what VPCs, what CIDRs belong to your VPCs across different regions or accounts. You can either take a screenshot of that and note it down for later, and then when you're making additional VPCs, you can refer to that. Or if you want to pay a little bit more money, then you can kind of rely on that to kind of dictate how your VPCs are going to be kind of created and how. But overall goal is to be aware of overlapping, so that you can make things like VPC peering much easier later on. And then when you have good VPC peering, then you can have infrastructure that can talk to each other across regions, which is really powerful. Okay, enough. So going back to this resource, yeah, I won't apply this, but yeah, you could have a VPC like this and call it main or whatever you want to call it. And then you would have a CIDR block, which would be 10.0.0.0 or to 16, and then you could have a name for that, which could be I don't know, VPC main. Good to tag. Good to do tagging though. Yeah, that would be a good way to start up a VPC. However, I'm not doing that right now. So I would do module, let's call this IPAM. IPAM, oops. And then the source to the module, which would be modules. And then let's just init this. Okay. Now let's go inside the module, inside the main.tf file inside of the module. Let's just get rid of this for a second. And so we will start with the IPAM itself. Come back to this. So resource, AWS VPC IPAM. And let's just call it main for now, or primary. And we will have cascade to true. You don't have to do this, but cascading is if you delete the main pool, then it will if you delete the main IPAM, it will then cascade to deleting the pools and the scopes within that. I can come back to this a little bit later. I have a little bit of a problem with AWS with this, but okay. And then the most important thing you have in this is operating regions. So you could just specify there you want EU Central 1, and then if you had multiple VPCs in EU Central 1, then you'd be able to kind of use that. But if I presume a lot of the time people want to kind of create VPCs in different regions as well, and this is where you'll specify a second block, like operating regions again, and then you might have EU West 1 or 3 or whatever. To be able to do that better, we can use a dynamic, and then we can have operating regions here, and then for each, we will create a locals here, and then IMAP regions will be a set of unique values, and then we would say we could actually just pull the, do I have this? Yeah. So one thing I might do is just add a data for the AWS region, call it current. That's good. And then do data.aws region.current.name, and then you could add an additional region. You can handle this dynamically however you want, as a variable or EOS 3. Then in this dynamic operating region, so we're creating multiple operating region blocks here. We would do the local.imap regions, and then in the content we would have region name equal to operating regions dot value. Let's apply that. Actually, one more thing I would do is just also say tags name, and then we'll just call it main. I wouldn't call this root because that will come on in a second. Too many function arguments. Oops. Apologies. Okay, and then that will create our IMAP. This is like the main space where we have all our pools, right? Second, we can just validate that, verify that in AWS there. So there we see our main, yeah. Then we're gonna create a pool, a swimming pool. Not really, but kind of, but also not. We'll call this root. And this will be the top level. So imagine like the highest of the highest. So the CIDR range for this is going to be huge. Millions of IP addresses you can provision at this level. 16 would be the biggest in a VPC, but you can go even higher with a kind of a root with a pool for obvious reasons. So the address family would IPv4. And then the scope ID would be the reference to the IPAM.main, and then we're going to do the private scope ID, because with this, in this case, we're looking at addressing the VPC with private IP addressing. I said addresses too many times. What else? So the other thing is you can look at allocation. Again, I might add cascade here. I'm just going to tidy this up. And come on to local in a minute. This, yeah. And then in tags again, I would call this root pool. Then we're going to add a CIDR to the root pool. So as I said before, like the biggest kind of the range that you're going to give to multiple different VPCs. So again, we'll call this root, and the IPAM pool ID would be what's just above. ID. And most importantly, it would be the CIDR, which would, now we're going to allocate something really, really big. So if we just clear this now and do IP calc, and we do, yeah, 10.0.0.0/10, that would give us, that would give us 4 million addresses to allocate across multiple VPCs and multiple accounts. There's a lot. Then it depends on what your use case is and what you're doing. But then we could go with something a little bit smaller. Okay, that's 1 million. So let's just go with that for now and do 10.0.0.0/12. Let's just get rid of this. And again, let's apply that. And we see what we're creating. Everything looks fine with tags. And yeah. Yeah, and then you can see the root pool's been created. And we have scopes that have been created. And then, yeah, you can see now we have a very, very large CIDR. So what do we do now? We could just create VPCs and start allocating CIDRs. And then when we create a VPC, we can reference this pool to grab different VPCs. However, I think the better way to do this, and this is what AWS documentation would say, is that you need to create kind of these regional pools that kind of sit below. So let's do that. We can also handle this a little bit dynamically with Terraform. So again, we're going to create another pool. This time we're going to call it like a regional pool. We're going to add a few more, before I forget, we're going to add a few more arguments here. So locale we'd also add, and then we'd also want to do the source IPAM pool ID. So we're kind of referencing the root pool here, and it becomes a hierarchical by nature. So the source IPAM pool ID would be root.ide. The locale, so because we have multiple operating regions here, we're going to again utilize IMAP regions here with 4 each, and then from there we can say local.imap regions. Again, same address family. The scope ID, again, similar, would be the pool. Would it be the pool? No, sorry, it's the AWS IPAM.main, private scope ID again. Locals would be the each.value. And then tags would be, I think we're almost done. Name equal, and that's the each.value, so that we're naming it good, and pool with a lowercase. Yeah, have I forgotten anything? Let's see. So let's apply this. This should create 2 resources more now. Yeah. Good strategy to know how many resources you're creating when you're doing it, because it shows that you a little bit know what you're doing. Yeah, it's good. So there's 2 identical pools we've created dynamically with a for each statement there. Let's try this. Let's go back to our pools. Okay, cool. So it's kind of worked. So these are our pools. We're not going to really kind of interact with the root pool hoods. We've made our CIDR, we've allocated it at the top level of all the kind of IP addressing we want to do for our entire Terminator network, Skynet startup that we're going to make that's going to rule the world. But you will go into a specific region pool, and then you can then provision a CIDR. Then we provision a CIDR, add a CIDR by size. So let's say 16, which would be the minimum, maximum that a VPC would be able to handle. And then we can provision this. So this would be in, let's actually do it in EU Central 1. So there's a better, because I don't have a VPC there. Provision a CIDR there. Again, we can use by size, like this. Provision. Okay, then we could also provision another space here. Also 16. That's an invalid state. Let's see what I've done. Probably because it was already provisioning. Yeah. And then a second one, provision this. That's also provisioning. And then if you go back to your kind of, again, your global pool, then you can see that, you've started to provision these IPs. And then you can start to, when you next create a VPC now, then you can create, you can basically select, hey, I want something from this pool we've allocated. Okay, you've already allocated 2 CIDRs, so it will pick one of them. And then if you create another one and do the same thing, it will pick the second one. If you pick a third, because haven't picked a third, then of course it's going to fail at that point and say there's nothing to provision. So you can kind of control how CIDRs are allocated. But this is great. This is solving the problem where you basically don't have this kind of networking overlap, which causes so much technical debt down the road if you don't get it right. So I think this is kind of like one of the good topics. You can then initiate VPC peering, yada, 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 yada. So I mean, just to exemplify, so if we go even with the UI now, and we can do it in Terraform as well, but in the next video, I can do this in Terraform. If you then say, I don't know, main VPC, IPAM allocated IPVPC CIDR block, you see then the drop down has already kind of picked our pool that we created from the specific region. So of course we're not allowed to then pick from the other pool from the other region, which was Paris. We're now in Frankfurt, so this is the one that's available to us. That's because I think we had enabled locale, which kind of restricts our regions. Great, my camera turned off. Okay, so then, and then you choose the IPAM pool and the net mask, which would be 16, which is what was allocated. I mean, we can allocate much smaller VPCs. It really depends on what your use case is. This would be the biggest kind of option available. And then create VPC, fingers crossed. Okay, cool, done. Yeah, and then you have VPC. So then if you went into, just very quickly, I'll show you before I end this video, if we go into then now the EU West 3 pool, you can then see that we also can provision a CIDR. You can see those 2 have been allocated to the other pool. So then this is a fresh pool. We can add 16 here, provision. And then if we go to Paris. We can then see we have something to allocate there. You can also create a VPC here, but you won't have an overlap. You will, by doing this, by using IPAM, you will stop overlapping from occurring, which is great. Okay, so in the next video, I'm going to look a little bit about creating subnetworks that could exist within a VPC, again with Terraform, some things to watch out for, how you can create subnets within that, looking at route tables, and then in subsequent videos I want to create, do a little bit of chaos engineering. I want to pull the wires out of the wall and see what happens. Of course, I don't recommend you do this in a production environment if you're working somewhere, but this is cool to see if we can try to emulate a black hole or something like this and mess around. But yeah, cool.